Okay, so let's look at another type of problem. So notice it gives us a coordinate point. So it says an observer for a radar station is located at the origin of a coordinate system. For each point, find the bearing of the ship at that point. Okay, so all of these up here, we were finding a distance. So here we found a distance. So now we're trying to find an angle measurement. So this is going to be a lot different. So -2, 1, 2, 3, 4, 5. So what it's asking is like if I were to draw this line here, what is this angle? So that's what that's saying. So the thing about it is when a problem is worded like that, I need to figure out, let me do this in a different color, what this angle is or what this angle is. Like either one is going to help me. So I need to draw a right triangle, and we've had actually problems like this. So I'm going to kind of figure out some things there and then apply it to the bearing problem. So what do I know? Let's see, I know that this is -2 and this is 5. So 25 plus 4 is the square root of 29. So then I don't even need this. If you don't want to, just use tangent. So tangent of this angle that we're trying to find is 5 over -2. So that's where you're doing like the tangent inverse. And so I have theta equals tangent inverse of -5/2. Okay, so that ends up being -68.2. Me personally, I don't like to put, when I'm trying to find an angle, I don't like messing with the negative sign. So I want you to go ahead and put, do that same process, but put it in as just like a positive for both of them. And that's going to give you 68.2 degrees. This is going to be a reference angle, and then you can figure out your other, like what they are in your other quadrants from there. I prefer to do it this way. It's just up to you. So I know that this angle right here is going to be 68.2. So you can, it's just how you want to go about it. This can definitely help you. So this is like 90, 180, 270. So 270 plus 68.2 is 338.2. Another way to do this is you could have found like this angle right here and subtract that from 360. It's just however you want to see it. So the bearing is going to be 338.2 degrees. Try number 2. I think it's a little bit easier, but it's like a different way of looking at it. Okay, so you're so when I grounded, we went 180 degrees from north to south now. So that's my bearing. I also want to talk about it in both of these from like this perspective that we talked about up here. So 338 degrees, we could say that it's north something west. So we're going to start up the north and we have to figure out what that angle measurement is. So I'm just going to take 90 minus 68.2 and I'm getting 21.8. And so it's going to be, you're going to start up north and you're going to go 21.8 degrees west. So that's the way of looking at this one. This one you can have a couple different answers. So you can start at south and you could say 0 degrees east, or you could say south 0 degrees west. So those are kind of weird. They're kind of their own things. Okay, so for this one, so a ship leaves a point on a bearing of, so this is that new type of bearing, for 2.5 hours. So remember, distance equals rate time. So this is going to be one of those problems. So let's start off with what this means, first of all. So it's going south and 34 degrees west. So this is 34 degrees west. Okay, so we're starting there, and we're going for 2.5 hours. Then it turns, and so it's going to turn, and it's going to go at like in a different location. So let's go ahead and draw that out a little bit better. So I have this. I knew I was going to run out of space, so I wanted to redraw it. I have this. Whenever it turns, go ahead and write like or draw like a new coordinate plane. So you have your bearings again. So north 56 degrees west. So I'm going to go like that. And this angle is 56 degrees. And let's see, it went for 3 hours. Okay, then it says if the ship's rate of speed is 18 knots, which is that's your rate there, find the distance that this ship is from the port. Okay, so this is probably not very accurate. I'm just trying to, oh, it's definitely not accurate because this is supposed to be longer. So we're going to pretend that that's beautiful. So we have this thing going on. So let's go back, and this was 34 degrees. So I'm going to put in some more numbers. So if this is 34 degrees, then 90 minus 34 is 56. So that is here. And notice, guys, that 56 is here. So this is going to be 34 degrees. I don't think that we'll need that, but we'll see. Oh, something else. If this is 34 degrees, this is 34 degrees as well. And 56 plus 34 is 90. So this right here is going to be my 90-degree angle. So I know that. I also know find the distance that the ship is from the port. I also know that. Something else that we need, we have the time for these two, but we also need the rate. And so it tells us the ship's rate is 18 knots. So I'm going to multiply this by 18 and this by 18. So 3 times 18 is 54. And 2.5 times 18 is 45. So here you can do, and this is like nautical miles. And so here, I mean, you could even do Pythagorean's theorem since this is your right angle. So that would be your hypotenuse. So 54 squared plus 45 squared equals x squared. And x should equal about 70.29 nautical miles. Okay, last one. So I want you to go ahead and read through this, and I'm going to underline the things I feel like are important. Okay, so this is what I'm going to grab out of the problem. And it's nice that they give us a picture. I think what I want to do is draw, this is kind of hurting my head looking at this, so I'm going to draw it in 2 separate triangles. Okay, so if you'll notice, we have 2 different angles depending on like where the whale is or where we saw the whale. And so I just made this y, so this is like y plus x, that's what this is. And then this one is just this small one right here. So that's what's going on with both of them. Okay, so this is called a double tangent problem because what we're going to do is we are going to find the tangent here and then apply it over here. So it's kind of like a systems of equations problem. So let's go ahead and get started. So, and it's called double tangent because you're always going to use tangent here. So I have 15 degrees, 50 minutes, opposite over adjacent equals 68.7 over y plus x. So there's a lot of variables here. Let's go ahead and start over at this one, and I want to show you how that one's a little easier. I'm going to go through that same. And again, if you start over here, that's why I started over here, because you're going to like get stuck. So this one is going to be the same process, opposite over adjacent. And so when I solve for this, cross multiply, and divide, and you are going to get 95.72 meters. Well, now I can apply that to that y, and now it makes that problem a little bit easier. So we're using like the substitution method. Okay, so when we cross multiply here, we're going to distribute this, which is going to be yucky decimal, both here and here. So I'm going to show you my work on that. It's going to be tangent 15 degrees, 50 minutes. I don't think I want to. And then times 95.72 plus x equals 68.7. So a lot of this is going to be in your calculator. So what you're going to do is distribute, and solve for x. And x should be about 146.52 meters. And so I believe that's what the question was asking. Let's see, find the distance traveled by the whale as it approached the lighthouse. So we're searching for x there. Yeah, so we found our answer. So our x is 146.52 meters. And that's it.